All right, hello everybody. Here comes a recap of Specialization and Trade. So we're going to talk about two people who can benefit from specializing and trading. Each person is dealing with the production possibility frontier. So person A has this PPF, person B has this PPF. So as these PPFs are linear, it means we're dealing with constant opportunity costs, which makes our life easier. And there are two things that characterize people's PPFs. One is absolute advantage. Another one is comparative advantage. So absolute advantage goes to the more productive person. And you can tell who has absolute advantage in producing one of the goods, for example, Y, by looking at the cutoff point on the vertical axis. Whoever can go further up has absolute advantage in making good Y. So clearly it's person B. Same thing for good X. Whoever can go further out when making good X has absolute advantage in making it. So again, that's person B. So person A clearly is not doing as well with either goods. So as you can see, it's possible for one person to have absolute advantage in producing both goods. When it comes to comparative advantage, things get, I would say, a little bit more subtle. So generally speaking, comparative advantage goes to the one who has smaller opportunity cost when making this stuff. And I can tell you right away that one person cannot have comparative advantage in producing both goods. So first, small opportunity cost tells us who has comparative advantage. Second, one person cannot possibly have comparative advantage in producing both goods. Third, we need comparative advantage to figure out who should specialize in producing which good. So for example, let's look at these two PPFs for these two people. So this picture is similar to the one we just saw, but it's more specific. We can see some numbers here. And let's figure out who has comparative advantage in making good X and who has comparative advantage in making good Y. Technically, we need to calculate opportunity cost for each person, for each good. Actually, for each good, we have to calculate opportunity cost for both people, right? And then compare them. So you can first do it for good X, and then calculate opportunity cost for person A, and for person B. And as you can see, without going into too many details, opportunity cost of good X for person A is 2. Opportunity cost for person B when making good X, again, is 0.75. So if you compare these two numbers, 0.75 is smaller than 2, right? So actually comparative advantage in making good X goes to person B. Similar logic when figuring out who has comparative advantage in producing good Y. So you calculate opportunity cost of making good Y for person A, person B, then compare these two numbers, and in this case, 0.5 is smaller than 1.3. So comparative advantage in producing good Y goes to person A. So that's how you do it technically. But there's a nice shortcut we could use. In fact, that makes things much faster. So you could notice that opportunity cost that we just calculated for good X, in fact, is equivalent to the slope of the curve. So that means that without even doing any numbers, if you're trying to figure out who has comparative advantage in producing good X, all you need to do is to look at these two PPFs and see which one is flatter. Again, because opportunity cost of the good on the horizontal axis is equivalent to the slope. actually we can write it down right here. It's equal to slope of person A's PPF. Then again, you can just eyeball these two PPFs, and whichever is flatter tells you which person has comparative advantage in producing good X. So B, PPF for person B is flatter, so not surprisingly, we can confirm that comparative advantage in producing good X goes to person B. And as you figure this out, you actually can immediately tell who has comparative advantage in producing good Y, because it's always going to be the other guy. So as simple as that. Without doing any numbers, you can just look at the diagram, figure out who has comparative advantage in making good good X, and then you will know that the other guy has comparative advantage in making good B. Now, we know that we need to know who has comparative advantage to figure out who is going to specialize in which activity. What does specialization mean? Well, if we go back to this graph, it basically means that one person should produce only one good. So as person B has comparative advantage in producing good X, as we know, right, he should go to this point. This is where the point of specialization is. Let me actually change the marker. So this is the point of specialization for person B. And this is the point of specialization for person A. All right, so that's the first step. And in fact, we skipped the starting point. So let's look at this diagram. So to be specific, we need to have a starting point. In other words, we need to specify where these two people were before they actually got into specialization and trade. So this point for person A and this point for person B are their starting points. In other words, these are the points where they were, again, when they were on their own. These points are basically determined by their PPFs, right? Their production possibilities. We know they must be on their PPFs, and by their preferences. So clearly, yeah, this person A likes good X a little bit better than good Y, right? So he is actually further down. But simply put, we pick these 2 points pretty much randomly, not randomly, arbitrary, just to use them as a point of reference, so we can compare them to where we find these two people later on after they specialize in trade. All right, so that's the starting point for person A. So this is what he had when he was on his own. Then he decided to take advantage of specialization, so he goes up to this point. So he's not producing any of good X anymore, only good Y, because this is where his comparative advantage is. Person B does the opposite, moves all the way to this point, and this is his point of specialization. Now, next step is to actually start trading. When trading, you need to agree on the price. So here comes the price. In fact, you can think there are two prices. You can think about price of good X and price of good Y. Remember, there are no dollars. There are no money in this economy. There is no money, sorry. So price of good X is measured in the number of units of good Y that one has to pay for 1 unit of good X, right? And there is price of good Y, which measured in the number of units of good X, then one should pay to get 1 unit of good Y. The thing is that these numbers are very closely related. So basically, if you picked one number, then you know the other, because this is the relationship between them. So Px is just 1 over Py, and Py is just 1 over Px. So basically, there is actually only one price, but depending on how you look at it, you either get price for good X or price for good Y. So there are a whole bunch of prices that will work. For starters, let's just pick one. And the another way to call it, you can call it trading ratio. Price is basically the trading ratio. Because again, it just tells us how many units of one stuff you're gonna pay to get 1 unit of another stuff. So let's pick a price that is one unit of good X for 1 unit of good Y, or the other way around. So the nice thing about one is that it's the same no matter how you look at it. So it makes both prices equal to 1. It doesn't have to be this way, but why not make our life simpler? Okay, so let's see how it's going to work on this diagram. So let's start with person A. So he's sitting at this point now producing only good Y. But, well, clearly he probably would be bored with only having good Y. He's being very efficient, but he's being bored. So what if he starts trading? So let's say he thinks like he's okay to give up 6 units of his stuff. All right, so he's producing 10. If he gives up 6, it will take him down to 4. So 10 minus 6 is 4. That's what he's giving to the other guy. And actually, the way it's going to affect person B, that will move him up from this point where he is being on his own while specializing, up to this point. So this amount of good Y goes to this, goes from person A to person B. But that's not the end of it, right? Because it's an exchange. So in exchange for this 6 units of good Y, person A is going to get 6 units of good X, because that's the deal, right? So he will go from this point to this point, and will end up being at this point after the exchange is complete. Person B, after going up while receiving 6 units of good Y from person A, is going to move leftward because he has to give up some of his production of good X, specifically 6 units. So that will take him to 10 units of good X, right? Because he had 16 minus 6 is 10. And of course, he got 6 units of good Y from person A, so it gives him 6 units of good Y. So 10, 6, that's his consumption bundle now. And for person Y, his consumption bundle is 6, 4. Again, based on what he had, what he exchanged, and what he got in return. So 6 units of X this is what he got from person B, and 4 is what he has left after giving 6 units of good Y to person B. Now let's see what we have in the end after specialization and trade. Actually, we can see a very nice situation, right? This point and this point are definitely better than those points these people were at in the beginning. So that basically illustrates benefit from specialization and trade. You actually can calculate gain they have in each good just by subtracting the initial amount of each good from the new amount of each good. But the important thing is that they gained, and actually you can also see that depending on how far they will go in terms of trade, well, we might see some changes. But if the price is given, that this black line is given and this black line is given. So this person A could have gone a little bit farther, right, to giving out actually 8 units, then it will bring him actually farther right. Okay, I'm out of this line now. But the thing is that for a given trade line, and actually another thing, they're supposed to be parallel. So now let's take a closer look at those trading lines, so to speak. So first thing, as I already mentioned, they must be parallel, right? Because they're trading using the same price, so they must be parallel. And again, as I said, no matter how far you want to go with your trade, you're always going to end up on those lines. So like if person A went only to giving out 4 units, he would end up being here. And accordingly, there would be an adjustment for person B as well. So he will end up being here. So there are tons of options, but in the end, basically, yeah, both people will gain. Next thing. Now let's consider adjustments in prices. First of all, who is gaining more in this situation, given that price is 1? You probably can notice that person A is a little bit better off because he is going farther out from his PPF, right? Person B is not going as far out. And that basically is determined by the price. So the higher is the price of good Y, the better it is for person A. But as it's this price of good Y is going higher, right? Price of good X is getting lower. That's the way it works. So let's say person B gets somehow pushy and is able to push the price of his good up. Because again, he's making good X, so this is what he's selling. So person A will be buying good X and selling good Y. So if person B is pushing price of good X up, what it does, it actually is supposed to tilt the price line further out. So you can see that according to this tilt, person B will be benefiting more from a trade. But as this line is tilting out, the line person A is dealing with actually will be tilting in. And it actually seems like I was too aggressive tilting this line. So let's make it a little bit less aggressive. Let's make it maybe just like that. So yeah, to stay parallel, this green line here will look like this. Now they look kind of parallel, right? Actually, again, it seems like I'm being too aggressive because you see, like the way I drew it, the green line for person A almost touches his PPF, but that's basically is the idea. So it's not quite touching it, but I think now it looks more or less parallel. So you see what's going on here? As trading line is tilting out for person B, it's actually and benefiting him, right? It's actually tilting in for person A, so person A is not having as much benefit from specialization and trade. So simply put, there is a limit for the price of each good that people would agree to go with, because clearly if we keep pushing price of good X higher and higher, at some point this trading line for person A is just going to merge with his production possibility frontier. And that means that he will be out of any possibility to gain from specialization and trade given this price ratio. Which means that he will not accept the offer for trading from the other guy. So how can we formalize it? We can formalize it saying that no one should pay more for a good than what their own opportunity cost of making this good is. Because when price of the good someone is buying becomes the same as his own opportunity cost, it means that they can just as easily produce the good themselves, and what they're going to sacrifice to get this good will be exactly the same amount. So they will accept any price up to their own opportunity cost. Anything higher actually will make them even worse than they would be on their own, because imagine like a situation when this line tilts even further out. So for this person that will look like this, and clearly moving along this price line will actually put this person under his PPF, so no deal if this person actually is rational. All right, so that's basically it for now. That's the last thing we wanted to learn here about the limits of the price that someone will accept when engaging into specialization and trade. All right, thank you for your time. I'm stopping here.